They're running a weed whacker outside my window, so I'm going to go on mute for a little bit here.
So good morning to all of you that are just joining. We're going to start this up here in about 1 minute. So please be patient for a short time and we'll be right back.
My little window says that attendees are still on hold and there's a start broadcast button. So I'm not sure.
Should be there now, Ed.
Sounds like that was taken.
Yeah. All right, yep, now we have people coming in. All right, so why don't we go ahead and get started? We've got some other people coming in, but they'll just, they can go ahead and come in when they're ready. So good morning, everyone. My name is Mark Thomas. I'm Executive Director here at DMSC. We're pleased to have all of you at our monthly coffee chat session. And this week we've got a pretty interesting topic. We have Mr. Robert Brown from Mitutoyo America, and we have Ed Morse from the University of North Carolina at Charlotte. So we're going to be talking about digital calibration certificates. And before we do that, though, I'd like to go through a little bit of housekeeping. Bob, if you could go to the housekeeping slide. All right, so here's how we're going to go, is that as we're going through the session today, you may have questions, and we certainly invite you to ask those questions. And the way we do that is on your right-hand side, on your control panel, there's a drop-down box that says questions. So you drop that box down and you'll be able to type your questions in at any point throughout the session. At the end of the session, we're going to go through these questions, and Robert and Ed are going to take a look at these questions and hopefully give you answers that are going to be useful to you. Another point is that because you're here in this session today, tomorrow you will get by email a recorded version of this session, and that will happen tomorrow afternoon, meaning 12 hours after this section ends. You should be getting an email with a link to the recorded session. So why don't we go ahead and get started? And Robert's going to be doing most of the presenting. So Robert, go ahead. Thank you.
All right, thanks, Mark. Welcome everybody. Good to be here. I think to begin, it's probably fair to give a brief introduction myself, and certainly I'll invite Ed to give a introduction of who he is, what he does. Robert Brown, I've been with Mitutoyo for more than 25 years, mostly in software development, R&D, responsible for Mitutoyo's data management, statistical process control, enterprise shop floor quality systems that also include gauge R&R and gauge management, which gives me some background and understanding of the topical content that we'll do today. Longtime champion of QIF, certainly have embraced and believe in interoperability standards. And so Ed and I have put together this presentation, and we'll walk you through it. But before we do, Ed, if you want to give a little bit of background on what you're doing.
Sure, thanks, Bob, and appreciate all of you for attending. So my name's Ed Morse. I'm the director of the Center for Precision Metrology here at UNC Charlotte. We've been around for over 30 years now and do a great deal of research in dimensional metrology and related precision engineering and high accuracy manufacturing. I'm also the chair of ASME's B89 committee for dimensional metrology. I participate in ISO standards, and I've been involved with the DMSC for a number of years, and I'm currently caretaker of the resources part of QIF. So I will turn it back over to Bob for now, but you'll probably hear me interrupting at times.
Thanks, Ed. Yeah, so again, further to how Ed phrased it as the caretaker or the chair of the QIF Resources Working Group, I chair or have been a caretaker for the Statistics Working Group. So have been on board and we're well implemented with QIF. The background on this presentation, just a bit of history, is, of course, I'm associated with R&D. We're a global company and parented in Japan. And one of my colleagues in Japan had a request for a conference that happened last spring, hosted by the SI BIPM folks. It was a global conference on a digital fair, essentially a findable, archivable, retrievable information from the folks who do unit standardization, and they're also very interested in calibration. And they had heard about the quality information framework, so I had given a presentation at a 3-day conference on the quality information framework. And at that time, I had heard of something called DCC, and they said, can you do DCC? And I had to look it up, and of course, they explained it to me, digital calibration certificates. And that actually, it struck a chord because I had been asked by a major calibration lab software vendor if it was possible to use QIF for digital calibration certificates. And you know, knowing the architecture and the use cases of QIF as I did, I said, yeah, absolutely doable with the respect of measuring doing a calibration on a measurement resource or a tool or instrument is not that different from measuring a artifact or widget for quality control purposes. So the idea was there, and out of that meeting, I was invited to present at the NCSLI Digital Manufacturing Conference last year, summertime. And in that one, I had heard more information about what PTB, that's the National Calibration Laboratory in, or National Standards Laboratory in Germany, was working on this. and they recommended that I reach out to them. So this presentation will be twofold. Number one, it's how the quality information framework can be used as is to render a digital calibration certificate, as well as expose to this group the work that is happening not only in Europe, but globally. There's a good deal of traction in what PTB is doing formally on developing digital calibration certificates. So to begin, again, I'll remind us all, whether you call it smart manufacturing or Industry 4.0, the first pillar is interoperability. Again, the ability of machines, devices, sensors, software, and people to connect and communicate with each other in unambiguous, well understood methodologies. And that's what we're here to talk about today. Now, very specifically, we look at the definition of calibration as given by VIM 3, where it is an operation that under specified conditions in a first step establishes a relation between the quantity values with the measurement uncertainties provided by measurement standards and corresponding indications with associated measurement uncertainties. In a second step, uses this information to establish a relationship for obtaining a measurement result from an indication. Many of us understand that our tools have to be validated for their accuracy and uncertainty. For instance, here I have a 150 millimeter caliper that will be shown as to how we can actually generate a digital calibration certificate using the QIF later in this presentation. So why calibration? Again, it is about traceability. It is about a certificate chain. It is traceable to the Standards International units, and it provides an end user with the confidence of the instrument measurement results. There's an ISO standard that governs the operations and process and procedures of calibration labs, known as ISO 17025, and all major labs get accredited to this standard. Now, what is a calibration certificate? It is documentary evidence that an instrument has been calibrated. The certificate provides information needed to establish traceability on the quality and the measurement accuracy of the device. Excuse me. Calibration certificates are often prepared based on the guidance that are put into place by an international laboratory accreditation cooperation and administered by accreditation bodies such as the A2LA. Now, specifically, when we look at what is a calibration certificate, there is certain structures and content that are required to meet the ISO 17025. Various information about the instrument, the calibration procedure, the calibrating organization, the reference standards that were used, the date, the as found, the adjusted. These are all aspects of a calibration certificate. Excuse me. So you got the name, the lab, customer details, address information, environmental conditions, temperature, humidity, pressure, certainly the values themselves, and then a statement. And these are, again, traceable. Generally, calibration is done against a set of master standards that in turn may have a certificate from the National Institute of Standards and Technology in its certificate chain. So this is again the traceability. So metrology traceability is a property whereby the result can be related to a reference through a documented, unbroken chain of calibrations, such that each contributing to the measurement that may contribute to the measurement uncertainty. The calibrations are provided in this document chain. The listing of the reference standards used in the calibration are carried in the certificate. And in practice, traceability is established using these standards in a manner that has been assessed to the clauses of ISO 17025. Now, most of us do understand what the quality information framework is, a unified XML framework standard for computer-aided quality systems, which enables capture, use, reuse of metrology-related information throughout the enterprise. It is a set of libraries for model-based definition, quality plans, resources, rules, results, and statistics. So how can a digital calibration certificate be cast as a QIF document? And this was the first question that was posed to me a couple of years ago. And very simply, a calibration procedure in my mind, it does prescribe the evaluation of a specific metrological characteristic, or multiple characteristics, of course, for a type of measurement equipment. This is a QIF measurement plan. The calibration results contain the as found or as adjusted observations against those standard references, for instance, gauge blocks, and this is a QIF result. Now, the measuring devices as standard references can be considered QIF resources. So that's the inspecting device information is referenced at the test point measurement level. Of course, it's very important to have a secure interoperable certificate because these are formal documents, and the quality information framework does support digital signatures. 3 methods are called out. I won't go into the details here, but there's a signature detached that goes over the content completely. There's enveloping, where it may be the signature is within the document itself, covering a range of elements and nodes, or enveloped, where it's the root of the document may be digitally signed. So now we take that 6-inch caliper, that 150 millimeter caliper, and if a manufacturer sent it to us on an annual calibration frequency, we have a calibration laboratory in Aurora, Illinois, that has a set of protocols in which we would calibrate that 6-inch caliper. There are a number of test points. We see an outside at 1 inch. We see an outside at 2 inch. We see outside at 6 inch. We've got an inside at 1 inch, inside at 0.2 inch, depth for 1 inch, and depth at 1 inch. You see the reference standards that we may use with a gauge block or a caliper checker or a ring gauge. Again, and those are calibrated in themselves. And this is what a calibration certificate would look like. It is a piece of paper that we would send off with the tool after we are complete with our calibration. So in looking at what we provide as a calibrated artifact inspection certificate, I look at what we have in QIF and how we would map that specific calibration certificate as a QIF document. In our certificate, we've got a header section with customer contact, gauge description, control number, issue dates. We've got a body, which is the test procedure, which also includes the test points, the tolerances for these different test points, the actual or adjusted results, the reference standards that are used, calibration dates, and of course some fine print. And then we've got a footer where we'd have lab information and a sticker that you can affix to the gauge itself with the calibration information. Mapping this into a QIF document, we see that we have the version node will support the time created, the sign-offs. We have pre-inspection traceability elements that can support customer organization, inspecting organization, report number. We have a measurement resource node that can specify the details of the measurement device. In this case, it would be the standard blocks or the ring gauge as an example. We've got the product, the description, which would be the caliper itself, let's say a model number and a serial number. The characteristics, again, are in the plan, as it were, with tolerance and nominal information. And then the results would have the device ID itself and the value. And as I mentioned, QIF does support the concept of a digital signature. So what I will do here to wrap up this section of the presentation is do a walkthrough of a sample QIF document that renders all of that information as a that a digital calibration certificate would require. The case I've used here is Mitutoyo America is the customer, and NIST would be the calibrating lab. This would never happen. NIST does calibrate our master blocks, but this is certainly something that they wouldn't do. But for demonstration purposes, it will suffice. So we've got a timestamp. We've got the employee name or the ID of the tech that actually performed the calibration. We've got standard definitions of which organization, what the designator is on the ISO 17025 under A2LA accrediting body. We've got pre-inspection traceability with the inspecting organization, NIST, street address, postal code. Customer organization, this would be us who would receive the certificate, our name, address, our number, our organization number, order number, report number, and a formal standard ID that's referenced elsewhere. For us, our file units are inch. And when we go to measurement resources, now these would be the standard blocks that calibrating equipment that we use to conduct the calibration. And in our example, we have a gauge block that would be used with its own calibration date and expiration date. We have a caliper checker with the same, and we have a ring gauge, and I see that I didn't put the calibration date or expiration date, but of course that could be done as well. The product, again, that caliper is a 500-196-30 is a product code, and the description is again, a 0 to 6 inch caliper. Characteristics, again, as we have the test points, we would understand it outside at 1 inch with its tolerance information. And I'll just go down the line as we scroll to all of the different test points. We certainly have a nominal, and if we're doing an offset, so everything is 0. Ideally, we have the plan, which would be the sequence of the calibration procedure on the test points themselves, and then we have the results. So again, whether it's a pass-fail, which measurement device was used, what the value is, very straightforward. And we go through it, and then of course we've got manufacturing process traceability, so we can apply the serial number, and finally the signature. So as you can see in this sample, the Quality Information Framework, QIF, does support all the necessary elements needed for digital calibration certificate. Now, I'll move to the second part of the presentation because as I led in the beginning, this work was done on request from a calibration lab who was interested in interoperability and how QIF might be used for their use cases, serving digital certificates to their customers. But we look at what the PTB has done with the DCC, and I'll just give you a little bit of background. I'm not an expert in this domain, but we did do a presentation. Ed and I were invited to their second global conference, attended by more than 600 national calibration laboratories around the world. And there's significant traction in what they're doing. And there's certainly, as we reached out to them and let them know what we're working on, they are definitely interested in harmonizing their work with our work, because they understand how the digital calibration certificate does fit into the information workflows for quality control in manufacturing. For those that don't know, PTB is it's a National Metrology Institute in Germany. It's a federal authority, public law institution, works under the federal government, and specifically the Federal Ministry for Economic Affairs and Energy. Similar to our National Institute of Standards and Technology in the Department of Commerce in the United States, and also the National Physical Laboratory in Great Britain. PTB is among the leading metrology institutes in the world, and again, it is a very, very good organization in developing and promoting standards use. Specifically, as we learned and working with PTB, is there was a funded development by Euromet, which is an organization for the European Association of National Metrology Institutes, whose project was to foster the development of harmonized digital calibration certificates at a national metrology institute level and for their calibration laboratories. Again, the focus is on machine interoperability, information about calibration in a way that can be used in digital workflows, in measurement science, calibration, conformity assessment, and industry. It is a work in progress, having started in June of 2018, with an anticipated funding completion date, I assume, of April 2023. When you look at their big picture in what they're trying to do, again, they understand that the benefits are driven down to the consumers in the ability to get away from paper, get away from email, PDF attachments, to actually have a way to take calibrated information and exchange it from one system to another. And even providing that traceability in the quality control documents that would be generated from metrology resources used to inspect product out of manufacturing. So they see the digital calibration certificates, again, being an interoperable use case between the National Metrology Institute itself, calibration laboratories, testing laboratories, and inspection bodies. Couple infographics here on their story. So I think the idea, the proposal was probably kicked around in 2017. They had their first German workshop in 2018, getting industry on board. Second national workshop was done in 2019, and they had their first international conference in 2020. 700 people, 100 nations. So this was a great avenue for us to expose QIF to a much larger audience in the world as we work on promoting the ISO standardization of QIF. They've been very active in evaluation of good practices, working specifically in now, again, grappling with temperature or pressure humidity, the types of fundamental environmental conditions that any quality lab would need to adhere to, and would be part of a traceability information workflow. They held their second international workshop, and that's where Ed and I had the opportunity and privilege to present earlier this year. They're conducting a summer school because there's a lot of people interested in what they're doing. The partners that they currently have, Siemens, Zeiss, Fraunhofer, Bosch, I guess the T-Mobile systems, Valeo. Again, it's a rather large consortium that's working on this, and the use cases are actually quite expansive. I think there was even one where they talked about vehicle emissions testing and how that calibration information could be streamed from a testing organization out to the front line. An interesting note here, of course, there are a lot of us in the digital transformation world that are really moving from paper to digital documents and understanding that we need machine readable documents. We need unambiguous machine readable content. And it's got to be interpretable. And again, the highest level that they've identified, again, machine controllable and promoting the use of the digital twin on the as inspected front. A little detail on the structure that they have in there. Quite honestly, it's not a very detailed, robust. It's very simple in its structure. There's administrative data section within its elements. That's a regulated area. There are measurement results, partially regulated. I'm assuming that partially regulated means there are certain flexibilities that need to be built in based upon either use cases or business models. Comments, certainly a non-regulated area. And again, a document, which is additional area. Again, building with all of these inputs on SI, Vim, GUM, CODATA 17025. These are the specifications that they are using to guide their development of the digital calibration certificate structure. Here's another slide that just shows a little bit more about the root element itself and on the nodes that were just described. And this is very interesting. Again, when we work in interoperability, we really do need guidelines, and they are very serious about developing best practices. They're currently working on proposals, as I mentioned, for a lot of lab environmental conditions to standardize that with documented best practices. And again, they've begun coordination with external experts. It was interesting at the second global conference. Again, it was the who's who of national calibration laboratories from around the world. NIST is participating as well, and they are, of course, they're very interested in promoting standards. They have a large client base who sends perhaps master or very unique artifacts for calibration. So they are also looking at building a suite of digital certificates. They want to standardize, they want to maximize interoperability. And here's an example of a sample certificate for, I guess that would be in hydrogen and titanium alloy. Who knew? But this is their plan. They are evaluating what PTB is doing in the digital calibration certificate. They're also they understand that it may need schema extensions to support some of the artifacts that they themselves are responsible for calibrating. The phase 2 is that they will work with staff, again, creating appropriate templates for calibration reports, because everything they do is paper-based today. And they plan to develop and implement appropriate digital certificate schemas for NIST. And again, they want to transfer the digital to US standards organizations and US manufacturing for the support of Industry 4.0. And ultimately develop a secure repository for these digital certificates and supporting a metrology cloud of integrated data and services. Again, NIST has been a great sponsor, a great promoter, a great advocate of interoperability standards, and Robert Hennish is a primary contact for this work that is happening. So the recommendations, as we wrap up this presentation, you know, it's clear that there are a myriad of SDOs, standards development organizations out there, and it's very important that we recognize that, and that we work as a community in harmonizing these emerging standards and aligning our development organizations, and again, a strategy as the DMSC is doing actually is very helpful. We should consider the concepts of what PTB is working on for future QIF roadmap, as measurement traceability is critical for enterprise quality control. We would do well to embrace the idea of good practices to further promote the disambiguity of interoperability. And again, there are a number of ways that we could do this. We might perhaps even reference a DCC in a QIF document. I think we should look to see what NIST is working on to bridge the QIF and DCC concepts, and continue to engage with PTB on their initiative, as they have good global reach to further develop interoperability standards for metrology use cases. If you are interested on more information on what PTB is doing for DCC, I would encourage you to talk to Dr. Siegfried Hackel. He's actually the CIO at PTB and is spearheading this work. And lastly, we are at the end of our presentation. So I would be more than happy, along with Ed Morse, to answer any questions that you might have. Thank you.
Nicely done, Bob.
Thanks, Ed.
I didn't feel the need to chime in at all. I did see a question popped up while you were talking. And the first question was, what about R&R results, if available? And I think this is a really good question. Now, I'll give my answer first before I let you give your thoughts. But so I think the appropriate context for this question is often when you are developing the uncertainty statement to go on a calibration certificate, you have some type A data based on some R&R measurements that were performed. And I think that that's really another step down this road, and we're not quite ready for that. So that's really the digital uncertainty budget, right? So not only do we have a statement of uncertainty captured in this calibration certificate, but there's a link that takes you to all that data. And that's the next step, and it's going to happen, but I'm not sure if we're quite ready to take that on yet. So yeah, not sure if you think the same thing, Bob, or?
Well, again, in the statistics section, and we were very careful, I think this was introduced even in 2.0, and it's certainly still there in 3.0. On the statistics side, we were very careful to be able to treat not only single part inspection, but multi-part inspection. So again, whether it's a first article inspection, QIF renders very well. Whether it's a 30-piece capability study, QIF renders that result and statistical summary very well. On the production statistical process control, we handle that. And we did make sure, and there are samples available on gauge R&R, linearity, bias, and stability studies. Now, again, they are, I don't know if they are rudimentary, perhaps by some standards, but I know that we have samples for those measurement systems analysis type studies that can be rendered in QIF today. Of course, how does that roll up in general uncertainty methods? You know, that's something that can feed back into the resource section. But yeah, we do gauge R&R today. Other questions?
Are you able to see the questions, Bob? I'm happy to manage this.
I'm looking at chat. I don't see.
Okay, so the second question we got was directed at you. Said, would you be able to make your sample QIF instant file available to act sort of as a reference or template for anyone who'd like to use QIF for DCCs?
Absolutely. Yeah. Again, robert.brown@mitutoyo.com, and I'll be more than happy to send it to you.
All right. So let me just make a comment about the template file. And so as I expect most of you know, QIF is really a data carrier. So it doesn't impose restrictions on the information that is moved around, but it provides an organizational structure. And the X in the XML, of course, is for extensible. So if what you need isn't there, you can always add to it. But we have to recognize that if everyone has to add things, then it's not a very useful standard. So we want to certainly support the vast majority of data that would appear in calibration certificates. So the template that Bob showed is certainly a great way to start, but I think we need some concerted effort within DMSC to make sure we have all the right stuff in there. And calipers are pretty straightforward. When we get into other instruments, this is going to be a lot more fun.
Mm-hmm.
Next question is from, I don't know if I should say, it's from Anish. He won't mind. Can this go beyond industrial metrology?
Ed, I'd pass that one to you. I mean, first of all, what's beyond industrial metrology?
Yeah. So, I think, there's the sort of legal metrology framework where calibration sometimes are important. And then there's this dissemination of the SI, and I see these are appearing in the comments. And certainly, I think industrial metrology is the largest by volume component of customers for the DCC, but I can't envision that we're doing anything that would prevent it being used in a legal context or dissemination of the SI. Certainly, that would be something we'd want to support. But there are probably a lot of political issues in getting 50 different state metrology laboratories to buy into using a particular flavor of a calibration certificate. But hopefully having something that is machine readable and well organized will help us there. Okay, next, wow, they're scrolling off the screen here. Next, oh, this one's right up your alley, Bob. How would you guarantee the authenticity of a digital calibration certificate in QIF? And what methods could a third party use to verify the origin?
Oh. Boy, I, for this presentation, had done a bit of research on the concept of, where is it? Of this information and how it applies. I am not a digital certificate expert. So as you'll notice here, I just put in the section from the schema without really understanding it. I do know, like I said, that you can reference a certificate externally. You can embed a certificate again, and these are private public pairs that again would have a certificate chain. How do you guarantee the authenticity? Again, I would have to give it to someone who is more adept at understanding digital signatures. I apologize.
I think one aspect of QIF that's well suited for this is the unique identifiers, the UUIDs, or what are called QPIDs within QIF, which certainly pertain to uniqueness, but as far as authenticity, would require some additional work. All right, so next question.
And by the way, PTB, again, since they're focused on this, is actually, there are some presentations, and I would invite you to go out there specifically for how actually some researchers at PTB themselves are ensuring the certificate authorities and their certificate chain is valid. So there is information out there in this subject.
Mm-hmm. So next question is, what do you think is the maturity of this tool related to multi-sensor CMM? And I think my answer is we're not ready yet. So we're still making sure that we understand what would be required for something as simple as a caliper. But I think we will learn a lot in that process. So even if we think that a multi-sensor CMM is 20 times more complicated than a caliper, I think we will understand over 50% of the problems as we develop the caliper calibration certificate. And I think that we, as an aside, I think that we have a lot to offer here, because the work at PTB so far, as Bob said, has been focused on temperature, pressure, humidity, mass, and they're not pushing this, that I'm aware of, very hard on the dimensional side. And the XML certificates are just a way of organizing the data. So the PTB DCC will be not any different in the information contained than a DCC that is modeled in QIF. So there should be a very simple exchange back and forth.
Right. And that's why I'd go back to Robert Hanisch. I think he does head up the calibration laboratory efforts at the National Institute of Standards and Technology. And as you can see, they've got a multi-phase program in place in which they anticipate they will be able to develop these secure repositories for digital calibration certificates.
That may also help answer the earlier question about looking at the authenticity, because there may be a check against that repository. Okay, next question. How does DCC work with audits and presenting evidence in that format? So I think, you want me to go?
I was just going to say again, what we're showing here is a proof of concept, right? This goes back to the maturity. It was asked, can QIF contain this information? And we've shown that it can. But as Ed said, there is a lot of devil in details that need to be worked out. So this is an emerging use case, I would say. And Ed?
Yeah, with respect to audits, I think that if you envision what an auditor would look for on the certificate, if the certificate is, well-organized format, then a person or a piece of code could easily access that information. Of course, the determination of whether the contents of that information mean that it's acceptable or not is what's usually left to the auditor. But I think having this in an organized fashion really enables a lot of better or more efficient work to be done as far as tracing back, does everything meet what we expect it to? And as a occasional assessor for 17025, I know a lot of time is simply spent looking at documents and asking questions where something seems to be a mistake. And if labs were able to run that process themselves, I think it would be much more efficient for them. All right. Oh, there's a comment here from Tom Kramer, one of our fearless leaders, and he points out that the QIF work on the FAI reports, the AS 9102 reports, utilize a digital signature, and that's been tested using publicly available tools. So the incorporation of a secure digital signature has been proven in other parts of QIF, so it should not be a difficulty for the DCC.
Excellent.
Question, will there be a free app that will allow you to view, print, or create PDF certificates based on the DCC? Because some organizations still, in the transition will require a paper or PDF. And I don't know that there will be a free generic app. Certainly there are XML readers that you can use to organize the information in a way that's easier to look at. And I think that given Bob's QIF template, we could create the Mitutoyo certificate from that data. I mean, all the data is there, right?
And there are people working on this. Again, I mean, I would encourage a lot of people who are asking this is to go to ptb.de, look at the wiki, look at the proceedings from the second conference. And this is open, and there is a lot of really good work here. And I recall seeing a presentation on exactly that, a viewer, as it were.
Yeah, that's a good point, Bob.
Yep.
Oh, here's a great question. I was going to point this out, but I'm glad somebody asked. Can we embed other calibration certificates within a calibration certificate? And I think this could be the great application of the digital calibration certificate, because your calibration certificate is required to have information about the standards used. And those are often hand typed or pulled from some database, and frequently are the cause of errors on calibration certificates. Or when you track down that path, you find out that the standard used was out of calibration, rendering the current calibration certificate incomplete. So I think that is certainly one of the applications that will really be enabled by this digital calibration certificate. Is you don't have a list of the standards you use, but you have a series of links which take you to their certificates in turn.
Right.
All right. I think we've reached the end of the questions, unless I got so excited about that last question, I skipped something. I think we've made it through there.
Yep. All right, back to you, Mark.
All right. Well, certainly, Robert and Ed, thank you very much for your insight on this topic. I think we saw from the number and depth of the questions that certainly there's quite a bit of an interest here, and obviously, as you pointed out, more work to be done, but it all looks very positive, and certainly there's some great organizations working on it, not only DMSC but PTB as well. So that's a good solid future here. So again, I want to thank Bob and Ed. Thank you for being presenters today. Everyone that's on the call here, I want to say thank you for participating, and not to forget to look for that recorded version of the session tomorrow. When you get that link to view the recording, I do encourage you to share it out with your colleagues. Certainly, if you had time to be in this session, other people maybe have interest as well. So again, thank you very much. And we'll see you next month with our upcoming coffee chat later on in June. All right, everyone, thank you.
Mark, thanks.
Right.
Ed,
Thanks
thank
very
you.
much. Yep.
All right. Cheers.